Hey, welcome to another live Wells training class. We are so happy you are here. And we got a great class for you today. It's kept us spinning for a while, I'll tell you that. Really cool stuff and some neat stuff about new vehicles that are coming out too, and how they're handling the current, going to different systems on the car. It's very, very interesting stuff.
Computer controlled.
We even had to call Mike Dale on this to help us out. And the way Mike says, hello. Okay.
All right.
So here we go. First, we'll start out with, yes, it's another t-shirt question. If you want one of these infamous, they are becoming infamous now, the infamous Wells Tech t-shirt. Okay, if you want one of these, you need to answer this question. On this circuit, right here, you can see we got the PCM down here, and battery plus up there. All right. And this is you know what that line means. Yep. That's the only thing in that component, right? This right here. What does this diagram right here mean? That part of the diagram. What is the name of that chip or circuit or whatever you want to call it? Okay. What is that component's name? Okay. There you go. Not an easy one. Yeah. All right. The vehicle that we're working on today is a 2006 Chrysler Town & Country, and it's got a 3.8 engine. Came in, had a P0404 on it, which means?
EGR problem.
Probably the EGR. You know why we know that? Yeah, we looked it up on Identifix. You know what Identifix told us? There were over 1,250 confirmed fixes saying EGR valve was bad. So
pretty common.
Yeah, I think we better go look at that EGR valve first. Pretty cool stuff. And by the way, we do have another video out that we did a few years ago talking about that problem, and why it happened. And yes, you're going to go out there and you're going to probably replace this EGR valve. There's a number of reasons that it could happen. That EGR Pinto could stick in there, which was the one that we were working on, right? That's what happened there. But more commonly, what happens is the position sensor right here fails. And the reason why it fails is because of this circuitry on the inside. This little circuit board right there, if you took that apart, you'll find out that's inside there. And that video, we do a good explanation of why that happens and how to test that. So that'll be in the link right down below. And you'll find out that what we did here at Wells, what our engineers did, is we improved that design of the circuit board so that would stop happening. Between the EGR engineer and our clean room engineer, they came up with this design, and we've been using it ever since, and we don't have any problems with it.
Exactly.
So there you go.
Great.
Great stuff.
Also, we're going to have another video linked down below just with basic EGR explanation of how an EGR valve, what it exactly does on an engine.
That's a really good point.
In case you don't know.
Right. In case you wonder why an EGR valve is on a car, let's go watch that video first and then come back and watch what we're doing here. And that'll explain it all to you very clearly. All right.
Well, should we get into it?
Let's get into it.
Okay. Well, for starters, why don't we go ahead and bring up the wiring diagram so that you guys can see how exactly this thing functions.
Yes.
Okay, so in our diagram, you can see right there in the middle, we have 3 wires, pin 1, 2, and 3, all go to our position sensor, which is just like a throttle position. Typical position sensor. Nothing.
Been around since 1980.
Right, yeah, nothing weird there.
Nothing odd.
But what's odd is here, if you look at pin number 4, that's going to go to one side of our solenoid, one side of this coil of wires right here. And that goes directly to ground.
That is correct.
Interesting.
And that is what that symbol means there, is a winding a wire. So what you have is a current coming out of the computer, pulse width driven.
Exactly.
And it's driving this winding a wire, and that winding a wire is, the other end of this winding a wire is tied right to ground. Okay?
Yep.
So how do they do that?
Well, the computer is going to use a circuit inside of it to pulse width drive the power signal. So when I say pulse width drive, that means it's sending out a pulsed signal, a signal with a certain duty cycle or a certain on time. So it'll go from 0 up to 12 volts and then back down to 0, a digital looking signal.
Right.
And then depending on how often or how long they leave that signal turned on creates a different amount of amperage in there.
The duty cycle changes that.
Duty cycle or on time.
And you know, when we started looking at this thing and to see how it actually functions, I was convinced myself that they would change frequency to change amperage level, because that's what we're talking about here is as this current flows through this winding, there's a magnetic field that builds up.
Right.
And the more current that flows through it, the stronger and more intense that magnetic field is.
Right.
Okay? So in my mind, we won't talk about that, but in my mind, it was, you know, if you do it more frequently, which is increasing frequency, that would increase amperage, but not true.
Right.
Okay, and we did prove that out, and we'll prove that out when we go over onto the vehicle.
Right.
And you know how I like to envision everything. If something is coming up, I like to have a vision in my mind, and this is how I envision it, okay?
Okay.
So if you look at it like a water faucet, okay, we'll use the water as electricity. And if you take that faucet, okay, and you turn it on and you turn it off equally each time.
Okay, same amount of time.
Same amount of time on, same amount of time off. That would be a 50% duty cycle.
Okay.
Okay, the amount of time on, amount of time off is the same.
Okay.
All right, so you're going to get 50% of that of the water that can flow through that hose will flow through that hose, and that and you think of that water flowing through that hose as the amperage. Okay, the actual current that's flowing through this winding of wire.
Right.
Okay, so what I thought is, okay, if you increase frequency, you do it the same amount on and off, but you increase how many times you do it, you would increase amperage. And that is not true.
Right.
And we proved that.
Okay.
Okay, which is very interesting to me. And so in order to increase amperage or decrease control amperage, okay, is what we're actually talking about here, is actually controlling the water flow through that hose or that current through this winding, you have to change the amount of time you have on compared to the amount of time you have off.
Right.
Okay, so if you have it on 80%, off 20, 80% on, off 20, you're going to increase amperage flow.
Right.
Okay?
Yep.
And by doing so, you're going to increase and intensify this magnetic field, and you're going to move the pintle that's inside of, I don't know which one to grab here, the pintle that's inside of here, you're going to hold it up at a higher amount and allow more EGR to flow through.
Okay.
Okay?
Right.
So that's how I envision that, is, you know, that you have to increase duty cycle in order to increase amperage or control amperage.
Duty cycle or on time, if you say we're at a 30% duty cycle, that means 30% of the time it's at 12 volts, 75% it's at 0 volts.
That is correct.
Then I would say that the valve is probably going to be about 30% open or so at that point, right?
I think it's 70%, right? Did you say 75 or 70? It's okay.
Yeah, okay.
The math didn't add up.
Yeah, okay. All right, so yeah, then the valve will be open that far.
Right,
and
exactly right.
You change that on time, it'll change how far the valve opens.
That's right. So yeah, your on time is what's important there.
Right.
But more important is your off time. You know, you have your off time, it has to add up to 100, right?
Yep.
So your off time has to be that. You know, and then your off time, and you'll see that when we start doing this, that it actually changes the look of the amperage draw through our scope, which is very interesting and really cool stuff. All right.
So in order to test this thing according to what we found out on Identifix, it talks about using the DRB3 scan tool, which is Chrysler scan tool. Well, we don't happen to have one.
No, we used to have one.
So yeah, right.
I'm lying.
So they're saying here that you should check it at, what they're having you do is you want to check the voltage output of the position sensor while the valve is at different positions internally.
Right.
So you're checking the position by a voltage reading. So they're saying here 30% duty cycle, the valve just starts to open. 35%, you should see about 3.2 volts. And at a 50% duty cycle, the position sensor should read about 2.2 volts.
So it equates it to a voltage that you should read off your position sensor.
Correct.
Right.
At a certain length of the pintle.
Right.
So when we went ahead and hooked up our scan tool, we were only able to show a 50% duty cycle. It only had one option.
Okay.
So we went and talked with our engineer friends
It's really cool. You know, we got all these guys running around here.
Yeah, they're able to help us out on this one because we don't have a DRB3.
Right.
They have what's called a signal generator. And what this tool will do right here is exactly what our PCM is doing.
Yes.
This will be our PCM in our circuit. We're actually going to operate the EGR valve off of the vehicle with our 12-volt power supply or our battery in this system.
Yep.
And then we're going to drive it with this signal generator, which will act as our PCM. So we'll be able to change our frequency, we'll be able to change our duty cycle, and show how this valve reacts and how the position sensor reacts.
An interesting thing that we ran into is it's actually 124 hertz, right?
Right, yep.
That's what we're at. And we'll be able to measure that with our DVOM.
Right.
Or,
yeah, you can test it a couple different ways.
And so we thought, being creative guys that we are, let's change that frequency and see what happens. What happened when we did that?
Well, when we dropped the frequency down, the valve actually started to rattle.
It was crazy. It was like, what the heck is going on here? But yeah, that would vibrate through the whole vehicle if that actually occurred.
Right.
So pretty cool stuff.
Yeah. So I guess now that we know how to test everything, why don't we just go over there and do it?
Are we ready? Yeah, let's go have some fun.
I think so.
Okay.
All right, I'll bring this along so we can hook this up.
Yeah, bring that along.
Okay.
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 All right, here we are with our 2006 Town & Country, Chrysler Town & Country.
Right, yep.
It's not a Dodge Caravan.
Not to be confused.
Okay. Yeah, they all look the same to me, I'm sorry. Okay, where are we going to start?
Well, why don't we just start with doing that test procedure we just talked about with the controlling the duty cycle and checking the voltage on the position sensor.
All right, let's do it.
All right, so right now I have the meter hooked up, and you can do a lot of these tests with a meter. We're going to show it both ways, meter and scope. So right now I got the leads running. One is back probed into the position sensor of the EGR valve on the vehicle. The other one is on the ground of the battery. So I'm going to go ahead and turn our meter on. And right now we're sitting key on, engine off. According to our test, should be 4.2 volts. You can see here we're at 4.03. I'd say this is probably in range. If we check the battery right now, it's probably down a little bit, probably about 11.5 or 12 volts. So I would say that this is in range. So why don't we, whenever you're ready, go ahead and turn the EGR valve on. And now our scan tool only has one option. You can either turn it on or off. So it just turned on. We're at 2.18 volts right now. So if we go back to our test here, you can see 50% duty cycle is approximately 2.2 volts. I'd say that the scanner is probably opening that valve about halfway, or 50%, and controlling a 50% duty cycle. And now what we can do is we can actually check that. So we verified the position sensor's moving, but say the position sensor didn't move when we controlled the valve. The next step you'd want to do is check to make sure that the PCM is actually sending out the signal to control that, to control the EGR valve. So what I'm going to do is I'm going to take my back probe and go into pin number 6, dark blue and violet, at the EGR valve, which is a control from the PCM on the power side. So go ahead, back probe into here, and got to get it lined up okay. There we go. And what we can do now is we can actually check the frequency, the hertz reading, and the duty cycle that the PCM is putting out. So on the meter, I'm going to go to holding down this yellow button, change it over to read hertz or frequency. We're at 124 hertz.
That's a good number to remember right now.
Right. This is our this is what our computer's putting out. It's telling the EGR valve to turn on and off 124 times in 1 second. Right. That's what that frequency reading is. We can go ahead and measure duty cycle also. Again, switch the meter over and hold down the yellow button. We are at 48.9% duty cycle. So right now the computer's turning it on 48% of the time and turning it off like 51 or whatever.
52, right.
It's got to equal 100%.
Right, yeah.
You know, math, not my strong point today. So these are all really good numbers. This is what our computer is able to do. So we're able to verify the control of the EGR valve and our position sensor. At this point, if the position sensor didn't move, like this one didn't move, I would say put an EGR valve in it.
And you don't need a lab scope to check it.
Right, exactly.
You know, you can do it right with your DVOM.
Okay, well I think that's all we need to look at on the vehicle.
Okay, we're off.
Alrighty, I'm gonna get the meter out of the way here. And now what I'd like to show is how to because our scan tool only has one option, how to look at those other options, the 30%, 35%, and look at those voltage readings accordingly.
Right.
So that's what we got this guy for, our pulse generator. So we'll go ahead and hook that up. And this is our battery, our power supply.
Right.
So we'll hook in power and ground here. I have the solenoid wired up, power and ground also. Hook that into the output side here. And then also this little box right here is a voltage converter. So we're sending in whatever voltage we want, and it's outputting 5 volts to run our position sensor.
Right, just like a PCM does.
Exactly. So why don't we go ahead and start with getting the scope hooked up. Actually, we can boot this up in the meantime, let it warm up. Okay. Get the scope plugged in here.
And by the way, when we do one of these things, we learn a lot too. And
Yeah.
You're going to find out a bunch of what we learned today. And this started out to be P0404. Let's look into it and see, how to test this so anybody can do it, that type of thing. Because what it said is you had to use the OE scan tool.
Right.
You had to have the DRB in order to do it. Well, that's a challenge to us because
right.
We don't have all the OE scan tools, and I'm sure you don't either. So if you do, give me a call. I'd like to come to your shop. But so you have to find out different ways, and you're going to find out a lot of the things that we learned in our journey through this discovery.
Right. Yeah. Fortunately enough for us, we might not have the DRB3, but we have an awesome engineering team and electronics team that had a controller for us.
We got all kinds of stuff around here that's really cool.
Kind of a nice little toy for us to play with here. What we can do with this is we can change our frequency reading, our duty cycle reading, and turn it on and off. So what I'm going to do is bring us back to that number. Remember that 124? I'm going to bring our frequency back to that, and I'm going to turn our duty cycle on, and I'm going to put it back to that 50% reading that we were just reading with the scan tool on the car.
Right.
And right now I'm hooked into our position sensor with one lead of the scope. The other lead is hooked up to ground. And if we go over to the scope here, before I even turn the valve on, right now we're key on, engine off. If you look on the scope here, you'll see we're at just about 4 volts. We're at 4.01 volts.
That's pretty close.
So I would say that looks almost exactly the same as what it did on the car. But why don't we just change our scale here and zoom it in a little, since we're only on a 5-volt scale. Let's take a look at what this looks like. Bring our flag down a little. So now we're at our 4-volt reading. So now what I can do is turn our valve on. We're going to turn it on to a 50% duty cycle, so halfway. And immediately you see our position sensor, move because the pintle inside the EGR valve moved and brought us down to that 2-volt reading, or should be very close to that 2.2, so 2.11 volts, right where we need to be.
You're right where we need to be. And it's interesting too, even though we're sending a frequency in here, we're holding that valve in a certain position, at a 50% on position. It's not bouncing back and forth.
Exactly.
It's holding in that spot.
And actually, I think I'd like to show that right now, of what changing that frequency. So if we were to send a different frequency into here, the valve wouldn't be steady. So I think if we go like this and bring us down to let's cut down to a 24 hertz frequency. So now the valve is buzzing. You can see our position sensor is buzzing like crazy.
It's going all over the place. And, and if this thing hangs off the side of the engine here, and if we were at a different frequency than at 124, that's why this is a really important number with this vehicle. The driver of the vehicle would his head be,
Right. Yeah, there's no way the computer is going to know where your EGR valve is.
Right.
So at 124,
maybe it would average there, but it's still
potentially.
Right.
At 124 hertz, the sweet spot, the valve is staying steady. It's not opening and closing like it just was.
Right.
So why don't we go ahead and change the duty cycle now? So what we're going to do is increase the on and off time, or increase the on time. So if we bring this up to a, say, 80% duty cycle, you can see right away our graph starts to lower down. So our valve is opening further, the pintle is opening further, and giving our corresponding voltage reading on the position sensor.
Right.
As we bring it back up, so now we're closing the valve. I'm going to go to that 35% number. So according to our spec here, 35% duty cycle, you should be approximately 3.2 volts. And this is where
it gets a little hairy.
Yeah. Right now we're at 2.694 volts.
Yeah, I think we're right.
Yeah.
I honestly do. And we tried a number of different valves and stuff too, and I think their specification here is wrong.
Right.
If you do have a DRB and you get the opportunity to check a vehicle like this, let us know what you're getting for a result. I'd love to hear that.
Yeah, it's saying we should have 3.2. We're at just under 2.7. That's half a volt difference.
Right,
is a big deal.
and that's half a volt is a mile away at this point.
Right, exactly. But just being able to control the duty cycle like this, so right now we're just acting as a PCM and we're opening and closing that valve. You can see by increasing and decreasing, it definitely is controlling our valve. So that is just excellent to be able to see, and it's cool that we had the opportunity to use this thing.
Yes, thanks, Ben.
So why don't we actually show what the duty cycle and the frequency looks like?
Let's see how they interact together.
Okay.
That's my favorite part.
All right, here we go. So I'm gonna
This is where I learn the most.
All right. I'm gonna take our scope lead and I'm gonna hook, I was on the position sensor, now I'm gonna hook right into the power feed or the control piece of this circuit. And you can see right now we just have a ton of what looks like hash marks on there. It doesn't really tell us much. Now there is gonna be a little bit of a difference when we use this, this driver piece, this pulse width driver. We're not able to control it on the high side.
Right. Yep. We didn't have the equipment to do that with.
Right. So in order to keep everything looking the same for you guys, exactly
we'll get into that a little bit later too.
Right.
Just what that means.
Exactly how it would be on the vehicle, we do need to invert our graph so that it looks the same because we're on the ground side now instead of the positive. Now if you're doing this on the vehicle, you won't have to worry about any of that at all.
Right.
It's just so that you guys can see it as you would see on the vehicle. So what I want to do now is I want to increase our voltage scale because we're not even on the screen. So there, I like the 20 volt scale, that looks nice, but you can see we just have a lot of hash in here. So we want to bring our time scale down. We want to take it down, let's do it 1 second, still pretty messy, 500. Starting to get clearer, we'll bring it down. There, we'll leave it at 100. So 100 milliseconds right here. You can see our pattern's kind of jumping around. I'm just going to throw a trigger on here.
And remember we talked about triggers and what they did last time?
Right.
So watch our last video if you have any questions on that.
Exactly. Okay, so this is a perfect representation of a 50% duty cycle. So you're off 50%, turning on 50%, off 50%, turning on 50%.
Right.
So what this is showing is, like we talked about with the frequency, the computer's able to control it like this and hold that valve in a certain place.
Right.
Without having to constantly be supplying power.
Yes. And that's a lot harder to control.
Right. You'd have to have like a variable type of voltage resistor or something in there to actually change the voltage reading to move this valve.
Well, we won't get into that.
Right.
Let's bring our cursors up and show.
Okay, sure. So with the scope, you can see the duty cycle. And actually what I'm going to do is zoom in a little bit further on this with our time scale. I'm going to bring it down. Let's go down to a 20 millisecond interval. So right now we're on 20 milliseconds. I'm going to bring our cursors in so we can measure our frequencies.
Right.
So I'll go to show. You can see our cursors right here, 1 and 2. So what you want to do to measure the frequency is you want to have one cursor at the start of the cycle, and then the other cursor where that cycle ends, where the next cycle starts. So put it right about there. So this is one cycle, so it's on, off, and a 50% duty cycle. Now we can measure our hertz reading. And right here, 124.38 hertz.
That's pretty darn close to 124.
I like it.
I like it too.
And there might be a little bit of, I might have this just off just a hair.
Yeah, and it doesn't take much, but it'll get you right into the ballpark.
Right.
It'll let you know whether or not you're on or not.
Okay, so we've seen all that now. What should we show next? Should we show?
Let's look at the amperage.
Okay, let's do that. Actually, did we show what the duty cycle does off of 50? Let's start with that.
Yeah, let's show that.
Okay. I'm going to go ahead and take our time back out here. We'll go back to that 100 milliseconds. And what I'm going to do now is control the duty cycle up and down. I'm going to bring it up to 80% first.
And notice where our cursors are right now. you can see that our frequency is actually not changing.
Exactly.
They're not in time to count 1 anymore because you change your scale, but they stay steady. You know, we're still at the same frequency.
Yeah, actually, if I were to just change this back to that same scale again, they should be at the start.
Still at the same
on
point.
one cycle.
Right.
So let me bring that back up. But now what you can see here is at an 80% duty cycle, so our valve is open 80% of the way, you'll see 80% on, 20% off, 80% on, 20% off.
Right.
And then vice versa, we go down, and you'll watch it adjust as I'm bringing it down. That's 50, 40, 30, go down to 20. Now it looks just the opposite. 80% off, 20% on, 80% off.
But our frequency remains constant.
Exactly, that hasn't changed.
Right.
So,
very good.
Excellent. Let's
can we look at the amperage?
All right,
now?
we can get there now.
I like that part.
You're so excited over the amperage. This is my favorite part though too. Okay, so what I'm going to do is take our amp clamp and just a normal amp clamp we've always used, hook into the scope. I'm going to go into our channel 2 and turn it on the 1 millivolt 10 milliamp scale, zero it out, and go on to our control wire. So what we're doing is measuring the amperage going into the valve or out of the valve.
The same way you would do it right on the car.
Exactly.
Same thing.
So let's turn on channel 2 and see what that looks like. I'm going to turn channel 1 off for a moment just so we can get that out of the way. And actually I'm going to bring our duty cycle back to that 50% mark where we were. That way we can always start at the same spot.
Yep.
So right now 20 volt scale is way too zoomed out, way too big. When you're using your amp clamp, remember you want to be down in the millivolt range. So we'll start at 500. That looks pretty good. Let's go down to 200. Okay, that looks nice.
That looks good.
So you could see here, we'll put that on there. You can see now our amperage reading is this thing running? Okay. Yep, our amperage is coming up and down, up and down. What's interesting is if we put a trigger in here, actually, what we'll do is I want to add that trigger back in from our first graph. So I'm going to actually bring our first graph back up here, channel 1. And you'll see, because it's triggering on that, or it was, must have turned the trigger off. Let me turn that back on. Okay, we'll turn channel 1 on. But you can see our cursors are still here, so our frequency is still the same. And you can see our amperage increases and decreases at the same amount of time when we turn it on and off.
Yep.
So amperage, the duty cycle turns on, amperage increases. Duty cycle turns off, it decreases. On, increases, off, decreases.
In an equal amount.
Exactly.
Because it is 50%.
And actually, I think I have this turned around the wrong way. Nope. Am I on the wrong wire? Yeah, I am. Okay. There we go. That looks better.
Now we got it.
Sometimes I get the wrong wire hooked up. There. And it wouldn't have made really any difference. It's still measuring the amperage.
Right.
But now we can actually show our amperage increase and decrease. So what I'm going to do is I'm just going to set it down here. So again, 50% duty cycle. Our amperage spike is the same. So it's 50% turning it increasing, 50% decreasing. Increasing, decreasing. So what we can do is change our duty cycle. Let's go to an 80%. And now what's happening is the valve is opening further. We're applying more duty cycle. You saw our amperage came up, and now we're turning it on. 80% off 20, on 80, off 20.
And the trick here is it's no longer 50-50.
Right.
Now we're at a 80% on and a 20% off, okay? And if we could do the main camera. Okay, and you got to remember what's happening here is it's actually controlling the magnetic field that you're building and dissipating off of this winding wire.
Yep.
Okay, so as the duty cycle is on, you're running current through this winding and you're building and intensifying this magnetic field. When you turn it off, that's the amount of time that you're allowing this magnetic field to dissipate.
Before turning it back on.
Before turning it back on. So if you control that amount of time, you're going to have a larger or a more intense magnetic field here, and you're going to pull that pintle up further and hold it at a higher position.
Right.
Okay, because your off time, the off time is a trick here. your off time is much shorter.
Right, exactly. Yep,
So
we're at 20% off.
Yeah, so dissipation, it doesn't have a chance to completely dissipate and boom, it's back up again.
Right.
That's what's happening.
And at that point, being that we're at a fast enough frequency, the amperage never drops low enough for the spring internally of the EGR to overcome the magnetic field to close the valve.
Yeah, it's the force of the spring against the magnetic field.
And we can show that happening by changing our frequency. So if we leave it at an 80% duty cycle, so we're still controlling that same amount of amperage, but we change our frequency down back to 24, our valve starts vibrating all over the table.
Right.
The pintle is bouncing up and down inside of there now instead of being steady. You can see it turns on, our amperage increases, and it turns off. And that spike is a lot lower now.
Right, and now because you're given enough time for that spring to overcome the magnetic field, we're getting this vibration out of here.
Exactly. So that's why this valve kind of has a sweet spot. So we go back to our 24, it's completely quiet. Our amperage
at 124 it works great. Anything other than that, it doesn't work real well.
Right, we can bring it up, the valve will start to buzz. You can see we're at 224, 324, 424, and it's starting to really buzz and whine, and kind of all the neighborhood dogs would be running away right now. But as we increase our frequency, you can see the distance between the high and the low spots on our amperage here actually becomes a lot closer together. It becomes a lot more steady.
Right.
So.
Very good. That's interesting stuff. That's real interesting. And I was convinced, you know, by changing the frequency, we were going to change the amperage output, but it didn't.
Right.
It didn't. It stayed constant. And in order to change that amperage, you got to change the duty cycle, or the on time, or dwell time, whatever you want to call it. The time that current is flowing through this wire, you have to change. Okay.
Right. And so, like, when we started this class, you talked about how this wasn't just going to be an EGR thing, and that's kind of exactly what the point is here. Is this isn't only happening on Dodge EGR valves anymore.
No, and what is actually driving this, what we learned through our association with Ben here, Ben is in watching us right now, and seeing how we're messing this up. But he was a lot of help, and also a lot of different engineers. We talked to a lot of people about this, and what we came to the conclusion that they're actually running this off of what's called a Mosfet. Okay, you want to explain your diagram?
Yeah, well, what we actually, our question here that we pulled up for you guys this week was actually out of a wiring diagram here on a 2013 Kia Optima. If we want to go to the diagram, you can see right here is what I had drawn on the board. And it says here it's a FET, or a Mosfet, and it's controlling our blower motor. So now we're starting to see these happen a lot more. This is exactly what's inside that PCM on our Town and Country. You have your power flowing in, and this is a ground side controlled one. Our Town and Country, it would be up here. But power flows in through the relay, through the motor, and then it's ground side controlled on the through the FET, through the Mosfet. So what is the advantage of that?
What is the advantage of that? You know, if you watched the position sensor on there, you would see that it happened in a linear fashion.
Yep.
So you're able to control digital output in a linear way.
Okay.
Right?
Yeah,
so,
exactly.
What the Mosfet allows you to do is set your blower motor at any speed.
So
you can pick any speed you want.
62.4%?
Right.
Okay.
And that's a little too high for me, so I like 43.1.
Sure.
You know, and you can pick anything you want. It's just not low, medium, and high anymore.
Right.
Right? Which is really cool stuff.
Yep.
And it can come into play for a lot of different things.
Exactly.
Like you were talking about theater lights and how your lights dim now.
Dimming now when you close the door?
Right. That kind of stuff. And that's how they do that. And you're going to see a lot more of these MOSFETs. And we're going to, when we come into it, and we get into a repair that involves that, we're definitely going to bring that information to you.
Yeah, so we can talk about like what is the gate and what is the drain, because those are kind of new things in the diagram. You don't see that all the time.
Yeah, I don't see that on transistors.
Right.
You know, so good stuff.
We'll have to have a class on that.
Yes, we do.
Okay, so what I want to talk about yet is why did Chrysler do this? Why did they run it on the high side versus the low side? Everybody else in 2006 was running low side drivers.
Yep.
Why do it on the high side?
Why did they do that? That's a great question. And you know what? We never did get a definitive answer. We asked a lot of people, and a lot of smart people, a lot smarter than we are. And nobody really had a a definitive answer. And this is like frequency.
Yeah, exactly. I have problems with that word.
But Mike came up with a good example as to why they may have done it. If
Sure.
you want to share that.
Yeah, I had kind of thought that maybe it was a fail-safe or a limp mode possible type of thing. So what I can show you here is I'm going to bring up that diagram of our EGR valve again. So again, we have our PCM here, EGR valve here, our pulse width power coming in, and our ground control. So if we were to short this wire to ground, everybody knows short to grounds are very common to happen on a vehicle.
It can happen anywhere.
Exactly. So if we were to short this ground wire to ground, nothing would happen.
Right.
The valve would still function completely normal. Okay.
And it
so
might
that's
even
great.
function better if you had a bad connection in one of those.
Could be.
Leads to the battery negative.
Could be. If we short the pulsed width power circuit to ground, our EGR valve would no longer function. It wouldn't have any effect on the drivability of the vehicle.
Because it would remain closed.
Right, exactly. It would remain completely closed.
Yep.
But it could possibly wreck the driver inside the PCM, but there should be some sort of protection inside there to shut the driver off
Some
if it's
sort of
short to ground.
thermal limiter or something going on there.
Exactly.
Right.
So this system right here would not leave you stranded at all. You wouldn't end up being stuck with the car.
Right.
If this were ground side controlled, so let's say now that this is our power wire coming in. This is 12 volts from a fuse down here feeding power into here. If you short this to ground, you blow your 12 volt fuse or your 10 amp, 15 amp fuse, whatever it is. You blow that fuse, EGR valve doesn't work, you can still drive around.
Right.
If you have a ground side control, so if this is ground side controlling it, and you short that to ground somewhere before it gets to the control, somewhere before it gets to your module, and you short this to ground and you're feeding it power all the time, you just opened up your EGR valve 100% of the way, all the time.
So when you pull up to a stop sign,
Yep.
your engine's going to die, and it's going to be hard to restart, you know,
Right.
if it restarts, that kind of
It
thing.
could leave you stranded.
And a tow job.
Exactly, yeah. You know, nobody told us that that's what it's for. We couldn't talk to any Chrysler engineer or anything
No.
of why they're doing it this way, but that just was kind of a sensible way of maybe they're making it a fail-safe type of
You know,
type of
when you
system.
have new technology coming out, and Cadillac is, you know, traditionally the leaders in this, they'll try different things.
Sure.
Okay, and they'll actually experiment on cars, and that might have been what was happening here.
Possibly,
you know, they wanted to experiment with Mosfets, and you know, can we actually drive something this heavy with a Mosfet and be successful with it? I don't know,
Right.
but it's a possibility
Right.
that's what they were doing with it.
Yep, definitely a possibility. So let's, should we see if we got any comments here? Nothing on there. It looks like, hey, there we go. So the answer to our question was, it was a Mosfet. And it
And
looks like
Hayward's Tire.
Hayward's Automotive.
All right, Hayward's Automotive. Hey guys, these are the same guys that won the GoTech
Right.
last time. So welcome, thank you. And you were absolutely correct.
It is a FET.
It is a FET. And I took a bet. I didn't think anybody would get it, but there you go. You proved me wrong again.
There we go.
Okay.
Well, I guess the main thing here is we saw this back in '06. We saw it used on a 13. We're going to be seeing it a lot more.
It is coming out a lot more. And, and another place, like you said, is like safety issues, things like that, like airbags and stuff like that. Just like you explained, what if an airbag would short out and it was, you know, driven on the on the negative side?
Yeah.
Bam!
You could blow that thing
Your
out.
airbags would go out. Off, you know,
Just because a wire rubbed
you
through
put
it,
it in
maybe?
a speaker and bam, your airbags go off. You know, you wouldn't want that.
Yeah,
That
it's
kind
a
of
safety thing.
It is a safety thing. So yes, you are going to see a lot more of these coming around, and as they add more features onto cars, they're going to have to use them. So very interesting technology.
Yep, and just remember, you're not always going to see what it is that's controlling it. Our diagram here, you don't see that there's a Mosfet in here. You just see it says EGR control.
Right.
It doesn't tell you what's in there.
Yep.
And it's not always going to.
And we're not absolutely sure, but we're pretty darn sure that that is a Mosfet in there taking care of that.
Like we talked about, that's kind of their secret sauce. They don't want you to know what's going on inside that box.
And this is where this whole thing led us. We never dreamt this is where we were going to go when we started looking at the repair on this thing.
Right.
But you know, when we do look into these things, every question that we have, we try to answer because I'm sure you're going to have that question too.
Sure.
And we try to get the right information to you.
Yeah.
Now,
All right.
Hayward Tire, you got a T-shirt coming. You want to send Mike an email?
Send me out the email with your shirt size and your mailing address, and we'll get one sent out to you. There you go. There's my email. Perfect.
And everybody else that answers that correctly, please do. We'd love to send you out a t-shirt.
Yeah. Looks like lunch is here.
Lunch is here.
Time to eat.
It's time to go. Okay, anything else?
That's it for me.
Me too. I want to eat. All right. Without you being there, we wouldn't be here, and we sure do appreciate it. We'll see you again next time in the Wells Tech Garage.
We'll see you then.
See ya. Let's go eat.
All righty.